Hello student, I am Arnab Das. Today we again meet together for continuing our topic related the feedback topology. To discuss this one topic we already discussed about various kind of amplifier. We also identify for the feedback topology the sampling network and what is the mixing network. And on that point of view, feedback topology are categories. Basically, four basic feedback topologies based on the parameter to be the amplified, that is maybe voltage or current, and the output parameter it may be voltage or current. The four feedback circuit can be described by the type of the connection at the input and the output of the circuit. That means for the last day class we just discussed about the sampling network and the mixing network. On that point of view, feedback topology or feedback circuit are classified, and already told this is four basic feedback topology are there. For the first one, if we consider for the series shunt topology, for the series shunt topology, here this is feedback one circuit. This is the feedback on circuit. Here the sampling network as a form of as a shunt. Look at this position again. I just repeat that. Here this section is defined the sampling network, and this one is the mixing network. For the sampling network, it is connected as a shunt form, and here mixing is connected as a series form. So here it is written as a series for the mixing, and here shunt is written for the sampling network reason. So if you consider in here the mixing is occurred the voltage term, because here if you consider here an internal resistance Ri is present, so this is voltage term is added on there, and for this reason this is voltage mixing is applied on that particular position. Now at the output side for this basic voltage amplifier, their sampling position or sampling network position, their current is applied as a feedback on there. Sorry, here voltage is applied as a sampling one, and for this reason this is denoted as a voltage sampling. Why this is voltage is sampling on there? If you just imagine for the basic voltage amplifier as the internal resistance as a R of 0, this is defined as the R of 0. So what happened for the R of 0? This R of 0 is connected as a parallel with the feedback resistor one. So here which term is as a constant or which one is the independent variable in here? This is the voltage term, and for this reason this is the voltage sampling is occur on there. Okay, so for the series shunt topology, their mixing is done for the voltage, and their sampling network is working for the voltage sampling also. Now we going to the another kind of topology, and that one is named as a shunt series topology. So in here for the shunt series, look at this position for the sampling one, which parameter is used on there as a sampling one. This is the current. Look at if you consider here as the internal resistance R is 0, and this is the feedback resistor is, as I say, this is the R of F for I, so it will be connected as a series form. So here which term is used as a feedback one for sampling case, it is current, and for this reason it is defined as a current sampling. And which portion is used for the mixing one on there? For the mixing case, looked at which one is added on there. This one is added, that is current term is added on there. So this is the current mixing is on there, and the mixing is used by use as a shunt circuit, and for this reason this is written as a shunt. And here at the sampling case, this is occur for the series one, so this is written as a series on there, and for this reason this kind of topology is suggested as a name of shunt series topology. For the third type of topology, what happened in here, um, you just recall your memory whatever till now we just discussed. For the sampling case, here current is as a sampling one, because here internal resistance if you consider for the basic transconductance amplifier, and here this is another one resistor you just imagine for the feedback network. That time this here the current term is used for the feedback one or for the sampling one, and for this reason this is defined as a current sampling. Okay, and if you go for the input side for the base transconductance amplifier, here this portion is use a series connection, and here voltage is used for the mixing one, and for this reason this is voltage mixing and current sampling formation is occur for the series topology. Why this is series? Because at the mixing type here the series connection is applied, and for the sampling type or network there also series is used on there for the connection point of view, and for this reason it is defined as the name of series topology. Okay, so now here for the fourth one is defined the shunt topology. For the shunt topology, what happened? For the shunt topology, there the sampling is occurred for getting the value of the voltage. So this is the voltage sampling. You just recall the previous analogy in which way I just explained. And here for the input side, there which parameter is used as a mixing one. This is the current. So here this is the current mixing is applied. To recall this one again, you just imagine this is the R of I. Here this is the R of FO for the output side feedback. So what happened? Their connection is the parallel one. So obviously, due to the reason of the parallel one, the current parameter is mixing on there. Okay. So this is current mixing and voltage sampling condition or formation is occur on there. And due to the connection at the input side for the base transconductance amplifier is as a shunt form for the mixing, and for sampling network here also shunt formation is used. So this is reason shunt. Here this one is used for the mixing one, that is the shunt topology name is suggested on there. We just go a little bit explanation by which it will be more uh, re- uh, requirement for getting the ultimate equation for individual type of topology. For the ideal cases series and feedback, what happened? For the ideal cases, as I told you that in here why this is series name is specified, because here mixing is occur as a series. Look that this is the series formation is applied down there. Okay, and if you consider for the shunt, why it is suggested as a shunt? Because at the sampling position their shunt connection is applied on there. This is the shunt connection is applied on there, and for this reason this is the series shunt feedback topology. And the equivalent circuit is look like this one. Here you just consider a internal resistance, that is the R of I, and their induced voltage is applied due to the reason of the voltage, this one V0, and the induced voltage will be beta into V0. Why? Because for this block, that is the feedback block, this side is indicate the input side and this side is indicate the output side. From here the output is come out. So here if you want to get the ratio between the output by of input, that time the beta is equal to which one is the input on there? Obviously the V0. So you have to put their V0 as a denominator portion, and the output will be defined as a what? This is the output is, as you see, this is V of F. So this is V of F is equal to what will be? V of F is equal to beta into of V of 0. Okay, so again I just repeat that it will be easy for the understand. If you able to identify a single one, then obviously the another one also easy for clarification. So here again I just repeat, this one is the feedback circuit. Here this side, that is the right hand side, is different the input, and this one is different for the output one. And we know that beta is defined the amplification factor. For the amplifier it is defined output by of input. So output is here defined as a V of F, as a V of F as a output voltage, because you are applying V of F due to the reason of series mixing. So this is V of F by of input is defined as a V of 0 due to the sampling. So this is V of 0. So what will be for the value of the V of F? V of F is equal to, this will be as a form of beta into a V0, and for this reason it is written as a induced voltage will be defined as a beta into V0 for the value of the V of F. Okay, so here also if you looked at for the A of Vi, why it is come on there, this is due to the reason of the induced one. And for this block, now you consider this one basic block. So here amplification factor is defined by the A. A is defined as a output by of input. So here for this section is used as the input, and this section is used for this block is defined as the output. So output is which one? Output is, you already can able to write down, this is the V of 0, and input is the V of I. This is the V of 0 and this is the V of I, because we know that this is the output by input as a ratio form. And the parameter why it is choose as a V0 voltage or input side also voltage, because for the series case their mixing is occur for the voltage one, and for the shunt as a sampling case their sampling one is the voltage one. So you just write down the equation in such way for the A equal to V0 by of V of I. So from here you can write down V0 is equal to as a into of Vi, and for this reason here it is written as a induced voltage is written as a into of Vi, and their internal output side impedance is provided as the form of R of 0 on there. Okay, so this is the total one circuit, equivalent circuit for the series shunt configuration. I think it's and everyone can able to understand. Otherwise you just for forward sorry backward your video, then automatically again this one can be easy for the understand. So now we go for the another one case, that is we are interested now to get the equation for the R of IF, where R of IF is defined that using the feedback circuit what will be the total input impedance on there. Okay, so what is the input impedance is defined, let this is the total one block, this is the red colored portion is defined the total one block. For this block here input is the V of S, and for this block output is defined as a V of F. So we are interested to identify for this block input side, if you consider a single impedance form, and that one is defined as a I of R of I of F. So what will be the value for the R of I of F? So this is as a obviously Vs by of Ii, because resistor value is defined the voltage by of current. So at the input side there Vs is the source and I of I is defined as a current on there. So if you just check on there, here for this block there II is used as a input current, II is used as a input current, and here voltage source is defined as a V of S. So here input impedance for the total feedback circuit will be defined as such. So you just put the value individual one, that is for the I of I it is written as V of I R of I. Ultimately the equation will become as a Ri 1 plus of A beta. Same way, if you calculate the value, that time the output resistance for the feedback due to the reason of the series shunt feedback, it will become as a R of OF, that is the total feedback output impedance will be defined as the R0 by of 1 plus of A beta. That means for the series shunt, their input impedance, total feedback input impedance, it is rising the value. That is input impedance will be high, and if you consider for the output resistance, that time it will be as a reduced one form, and it's reduced as a form of factor of 1 plus of A beta, 1 by of 1 plus of A beta as a factor form. So for the series shunt configuration, their input impedance, effective input impedance will be high, and effective output impedance will be low on there. So this is the thing I think able to understand each and everyone, and I think today this will be uh, the entire class. Next day we explain for the another kind of circuit, and ultimately we summarize various kind of feedback topology. So till I have to say good day and bye.